Start a counter for 27 minutes. Start a counter for 27 minutes. All right, let's start a counter for 25 minutes. Oh, okay. All right, so let's go. Yesterday I was right about to implement the part 1 of day 8. Let me complete it. It's a bit long one, but let's go through it together to remind ourselves. So here is the position. We read the positions, they're like this. They're in the three-dimensional space. And we basically go through them and calculate the distances. And we put them in basically in a tuple, okay? And we say, okay, between these positions, the distance is this, okay? So it corresponds to this tuple, and we return a list, right? And then we sort them according to the distances. So we have the shortest one at the start and the longest distance positions at the end. Then we have these stateful variables that represents the state over this while iteration that we're going to take. We need to remember some things. And here are the things. We have to remember, so we are grouping them. Basically, once we connect two junction boxes together, there is a circuitry, and the circuitry has an index or like some kind of identifier, right? So probably it's not a good idea to call it index. I would actually like to call it ID. So that, yeah, it's just an ID basically. And we start from the -1. And then we also have positions to circuitry indices. It's now it also needs to change. It needs to change to IDs, circuitry IDs. So for each position, basically, you are going to map it to which circuitry ID that it has. So, and we have how many junction boxes that we've paired, and also we have this distance index because we're going to iterate over this distances array, right? This will iterate 1000 times at most. Either we are going to pair 1000 junction boxes and we'll stop, or there will be like less distances like this, okay? So you can't make a junction of yeah, you can't do 1000 junctions connections. So you're going to check, okay, so basically you can have at most 20 different distances here, because in that case everything is distinct. They don't have any connections or whatever. But yeah, that's like, yeah, I couldn't explain clearly a bit probably, but once you understand the problem description, it becomes clear. Right, so then I do, let me try to remember the question. Then I expand these distances. I have this position 1, position 2, and the distance. And I decide both of them are single. They're not in part of a circuit. First single, second circuited. First circuited, second single. Both circuited same in the same circuitry, and both circuited different circuitry. And according to that, I'm doing some things. And I think merge indices and count indices are the missing ones to fill. So let me change that by positions to IDs dictionary. Both of them are going to have, and then it will have the old ID and the new ID. Merge indices, the goal of it is once you have some positions to the IDs, kind of structure, you'd like to update the structure in place to have the new ID instead of the old one, right? So that's one thing. Perhaps we can go through it like directly right now, okay? Let me keep it here. So one example value here is 1, 2, 3. It's a tuple. This could be the position, and it can have the ID 5, 9. All right, and then you'd like to turn 9 to 10 for whatever reason. I mean, there can be 1, 5, 4, 3. You can have 9 as well, right? And the other could be 1, 10, 1, 2. It goes to the ID of 10. I don't know. So here in this case, you're going to represent this as something like 9 has these positions 1, 2, 3, and 1, 4, 3. Like if you, I mean that's one way to do it, right? 10 have these positions, and then once you have this structure, you can say, okay, let's go and update this position to have 10. And then let's go and update this position to have this value. Let's do that. I feel kind of tired, but let's see. Let's see. It's always exciting under this circumstances. Like probably no one is watching, or you might be the only one watching. But the fact that it's being recorded and the fact that it is evaluating my skills, it feels personal for some reason, right? And if you care about what you do and it's that kind of stuff. Anyways, just wanted to share. All right, let's go ahead and do it. Basically, we're going to iterate over the dictionary and fill this the other dictionary, IDs to positions. It will be a dictionary. Okay, by the way, I learned how to disable it today. Something inline. Inline suggests, I think this one. not this one. Could be this one. Cursor. It's editor. Okay. This, I think this is. Or maybe I need to start it again. Cursor. Okay. Let's go cursor settings. Okay, I'm not able to. So probably it needs to go for VS Code settings. Enabled. Refresh. Interesting. Is it? Could it be this? No, not these. Like, yeah, I'm trying to. Okay, once you reset, it's enabled. But how do I disable it? I don't understand at all. Anyways, I gave up. I don't have enough time. So, dictionary IDs to positions. Okay. For position and ID in position to IDs dictionary items. IDs to positions ID append position. The only thing here is if ID not in here, just initialize it. Alright. Otherwise, you can go ahead and do this bad boy stuff. And then you have the IDs to positions, but not yet. You have to you have to positions to change is the ones from post IDs dictionary. Okay, so we have the old ID, and we are going to get the positions from IDs to positions, right? There are the positions to update, and for position in positions to update, we are going to update the pos to IDs dictionary, pos new ID. I'm guessing so. Can we do the following? Let's run it. Let's state, okay, so this is the positions to circuitry. So index 2 is 2. So the ones with 2, this and this, will be mapped to 1, all right? These two. And let's skip this. Yeah. So old ID, new ID. Yeah, these two will change, and let's check. Yes, they are changed, nothing else differed. All right, so I think this is working fine. Let it go. Now let's implement the count indices. So you have the positions to IDs dictionary, and you're going to count not indices. This is also not merging indices, but merge. Okay, it can say like this: count state indices. So basically, you're going to count the IDs, and basically, we really don't care about the structure. As long as this is something that we can return as a list, we'll sort it and we'll take the last 3 elements there. So in this case, let's read it whatever we like. We're going to return basically this thing. Something happens, and we'll return the result. So it can actually be like I would imagine something like ID counts. It can be a dictionary. It will have the integer with the ID, and then the count which is also an ID, right? Yes, please. For pos ID in pos to IDs dictionary, ID counts ID if ID in ID counts ID equals 0. The position, you really don't care. You're just interesting about the frequency of the IDs. and then you can say id counts, values, and you can return the list of it. Interesting. Why is that the case? Well, when we come here, when we come here, what do we have? We have positions to indices, positions to circuitry index. They're all 5. Huh. Is it the case? Actually, yeah, probably you'll always connect them to each other because you're trying it 1000 times, right? I think it makes sense. Perhaps we can try it with the actual input. Okay, here it also failed for some reason. What is happening? Let me delete these things. Oh, maybe we need this one. Do we have any other print? No. Shall we run you? List index out of range. But okay, it ends for some reason. What do you have here? Print counts. I don't know. Maybe I can go over it like this. How come they all become connected? I don't understand. So we have, they're in the different, they're both single, naturally print, I don't know what I'm printing. So here they're both single. Is there something that I can check like at the end of each? I don't know, maybe print positions to circuitry indices here. They all have the circuitry number 200. Why is that the case? That doesn't make sense. Once you connect them, connect together the 1000 pairs of junction boxes. 1000 pairs of junction boxes. Like when we connect two of them, I'm so sad right now. And a bit angry to myself as well. Ah, no. Okay, okay, 10 minutes, it's okay. Start a counter for 10 minutes. I mean, when you connect like two of them, you said one pair are connected, right? How does it actually work? Distance index, it's always increased. What can I print here so that I can see? The stateful variables, right? Latest circuitry index. What was the fancy way of doing this? Was it latest circuitry index, but you do it something like this? No. There was a way of latest circuitry ID something. Yeah, anyways, so let's print this one. Also, what can we print? Paired counter and print distance index. So somehow we identify both circuited same all the time, I think, right? These are all identical. Okay, so suddenly it becomes this and something happens there, and is it possible that this is not working as expected? Like, when do we... Okay, so I think it's going well, right? 0, 1, 1. What happens? So when we come here, we say we look positions to circuitry in this in IDs are like this, and we like to change 96 to 43. Ugh, I skipped. Anyways, Yeah, as you see, I somehow don't change anything about, like, basically after some point they're all connected to the existing circuitry. Hmm. I think the best idea right now is just trying to understand the problem here. Maybe. Wait. Oh, yeah. Okay. After making the 10 shortest connections, let's try this logic with that then. Like, we'll just have the test one, and n connections, we can call it as, let's make it 10 right now. So as a result, we are expecting one circuit which contains 5 junction boxes. So 0 has 5, yes, right? um, 5 5 for one circuit contains 4 junction boxes. Is it 1? Yeah, 1. No, 1 is also appears 5 times. Hmm. uh, okay. Okay, so the others we haven't really processed probably at the moment. But it's really interesting that this one, like, we have 5522, and apparently this one has 542, and then the rest is our 1111111, right? um, so I'm maybe I'm increasing the counter a bit more, because apparently I have start a counter for 10 minutes. Apparently I'm making a lot of connections right now, it seems. So in order to have 5 connections, I need to have 4, right? For this one I need to have 4, and for this one 1 1. So I do basically 10 connections. How come this one has like 4 connections, 3 connections, 1 connection? Like, after making the 10 shortest connections, like, nothing happens. Like, what do you mean nothing happens? Do you do the connection? Apparently you are doing it. Like, after making the 10 shortest connections, there are 11 circuits. I mean, makes sense. There should be 11 circuits, true? Wait, no. Making 10 shortest connections. One circuit which contains 5 junction boxes. Wait. 10 short, okay, which contains 5 junction boxes. To connect Wi-Fi junction boxes, you need 4 connections. To have 4 junction boxes, you need 3 junction boxes and 2 circuits with contain 2 junction boxes each. So they have 1, 1. So it actually made 9 connections right now. Am I missing something? Like one circuit which contains... I don't understand. I don't understand. I'm getting mad right now. Can you make it like... Okay, imagine you have, yeah, 1, 2, 3, 4, 5, right? And they all have connections. So like 5 junction boxes, 1, 2, 3, 4. Wait. Okay, apparently it made 5. Alright. One circuit which contains 4, 1, 2, 3, 4, and it has this much, right? So that's good. And 2 circuits which contain two junction boxes each. One, two, and they're connected like this, right? How many we have? Yeah, I don't know. Perhaps you don't need this one, right? Like if you have something like this, it's also connected. This is also connected. I think it should appear something like this. Now we have 4, 7, 8, 9. We have 9 connections. I don't understand. Oh my god. Oh my god. So we have 5 junction, 4, so it's 9, 10, 11, 12, 13, and they're like 7 not being used ones, right? They're not connected at all right now. Could there be like a bug or something like that? Is it possible? Like maybe, like as you see, there are like 4, 7, 8, 9 connections here, but it says 10 shortest connections. Like if I were to stop at number of connections are 9, for example. What's we have 5, 4, 2, just like what it asks, right? I don't know, maybe I should do 999, but like is it 1000 that we want to see? Yeah, something like this. Wait, sorry, input, but I think it will be, yeah. Okay, I gave up. I'll take a look at the comments if there's any, but uh, You can see it from my face probably. Like I I'm missing something. High likely. I'm not like this. All right. Let's go and stop it right now. I gotta go. Have a nice evening, folks. See you.